Hey guys, today we're talking about algebraic expressions. Alright, so there's a couple definitions that I want you to make sure that you have written down. A variable is a symbol that represents an unknown quantity. So make sure you have variable written down. And an algebraic expression, such as n plus 2, is an expression that contains variables, numbers, and at least one operation. So you can just give this example, algebraic expression n plus 2. Okay, an expression does not have an equal sign. Okay, so just to recap, a variable is a symbol that represents an unknown. Okay, so the variable in this expression is the n. So in n plus 2, that's the expression. All right, so characteristics of expressions. If we have a numerical expression, it has only numbers. Okay, so only numbers. If we have an algebraic expression, it has variables and numbers. And both of them contain an operation. Okay? All right, so pause the video, make sure you have that all written down for me. All right, so math that involves expressions with variables is called algebra. In algebra, the multiplication sign is often omitted. So we don't need that multiplication anymore. We just leave this, no gap in between them means that it's a multiplication. So 6 times d. This one would look like 9 times s times t. This one would be m times n. And this one would be a times itself 3 times. So the numerical factor of multiplication expressions that contain a variable is called a coefficient. So 6 is the coefficient in front of d. All right, so when we look at this, this right here is called the coefficient. So make sure that you have that example. All right, and something like this, when y is divided by 2, can be written as y times 2 or y times 1/2. Ooh, whoops, sorry, that's supposed to be a division sign. So that would be like a y divided by 2 or a y times 1/2. All right, so let's look at some examples. They want us to evaluate 2 times the quantity of n plus 3. So this is like a distributive, right? This would be like 2 times n plus 2 times 3. So what we do here is we can solve this by plugging in a -4 for n. So 2 times -4 plus 3. Oop, I closed my parentheses too soon. Plus 3. There we go. Okay, so how do we solve this? Well, we know that 2 would stay on the outside, and we do what's on the inside. A -4 plus 3 would be a -1, so the answer would be -2. Okay, let's look at a couple more that we can evaluate. What if they have 2 variables? Well, we plug in what they tell us to for both. So for w, we're going to plug in 5, and we're going to multiply it by 8, and then subtract 2 times our v, which is 3. So 8 times 5 is 40 minus 6, which would be 34. Okay? For the last one, we're going to plug in only the y. That's all they give us. So 4 times 3 cubed plus 2. Okay, in order of operations, we first look at the parentheses. There's no operations within it. So let's evaluate the exponents. 3 times itself 3 times. So 3 times 3 is 9, times 3 is 27. So this right here would be 27 times 4 plus 2. Remember, in this unit, you can use your calculator, so double check your work. 4 times 27 would give us 108, and 108 plus 2 would give us 110. So make sure you always double check your work. Okay, so here's what I want you to do. I want you to try these problems on your own. Go ahead and pause the video. When you're finished, I want you to double check your work with the calculator, okay? In about a couple seconds, I'm going to show you how to do each one of these problems. Okay. Okay, so here we go. For A, we're going to plug in 8 for C, and we get 5. For B, we're going to plug in a 8 for C, and we get 15 minus 8, or 7. For this one, we're going to plug in both 8 for C and a negative 5 for D. So we get a total of 8 minus 5, which is 3, times 3, which gives us 9. For D, we have to plug in both C as 8 and negative 5 for D. So we get 16, and this is a negative times a negative, so it's a positive 20. So we get 36. For this one, we're going to plug in a negative 5 for D minus 8 squared. So what we have here is a negative 5, and 8 squared gives us a total of a negative 64, and a negative with another negative is more negatives, so negative 69. All right, make sure you always double check your work with your calculator before you watch my explanations. So for this one, this is a negative 5 being squared plus 5 times my negative 5. So we've got a negative 5 times itself, which would be 25. And we're multiplying that by 2. So we get 50 over here. And to that, we're adding a negative 25 because 5 times negative 5 is a negative 25. So really, it's like subtraction of 25. So our answer would be a positive 25. Okay, let's try this one. An athletic trainer uses the formula 3 times 220 minus A divided by 5, where A is the person's age, to find their minimum training heart rate. Find Latrina's minimum training heart rate if she's 15 years old. So what we're doing is we're plugging in 15 for A, because that's the age. We're going to divide this whole thing by 5. So we first need to take 220 minus 15 and get 205. So we have 3 times 205, and if we multiply that by 3, we get 615 divided by 5, which would give us 123. So 123 beats per minute. Okay, let's look at another one. To find the area of a triangle, we use this formula, base times height divided by 2, where b is the base and h is the height. What is the area in square inches of a triangle with a height of 6 and a base of 8? So let's plug in 8 for our base, 6 for our height, and what's 8 times 6? We should know that one, or use your green sheet, which would be 48, divided by 2, which would give us 24 inches. Okay, let's look at this one. What if we wanted to translate a verbal phrase into an algebraic expression? The first step is to define the variable, and then make sure we represent it as an unknown. So Marissa wants to buy a DVD player that costs $150. She saved $125 already and plans to save an additional $10 per week. Write an expression that represents this equation or this situation, okay, to see how much Marissa saved after any number of weeks. Okay, so we know the DVD player costs the $150. She has a savings of $25 plus $10 per week. So let's let W represent the weeks. So we have $25 already plus 10 times W. So this represents the total number saved after any number of weeks. Okay? So this 150, was it really useful? No. The only time that it's useful is if we wanted to set it equal to the 150 and solve for how many weeks she would need to save the $10. All right, so you try this one. Go ahead and pause the video. Okay, make sure that you pause it because I'm actually going to go through it right now. So on this one, Leah has already read 20 pages of a book. She plans to read 5 pages a day from now on. Write an expression that represents the number of D days that she will have to read. Okay, so we've read 20 pages in the book, and she reads 5 pages per day. So our expression would be, we can even rearrange it, 5D. Oop, that looks horrible. Let's try that again. 5D plus 20, or 20 plus 5D. All right, try this one more. Go ahead and pause the video, and I'm actually going to go through it. An MP3 player costs $70, and a song download costs 85 cents each. Write an expression that represents the cost of the MP3 player and X, the number of downloads. Okay, so let's start there, and then we'll find the 20 songs downloaded. So the MP3 player costs $70, and then we also have to spend 85 cents per song. So there's our expression. They want to know how much it's going to cost us if we plug in 20 for our number of songs. So when I plug in 20 times 85 cents is 17. If I add 70 to that, I get $87. So it's going to cost, the total cost for 20 songs is $87. Oh, for 20 songs and the MP3 player. Okay, make sure you have a complete sentence answer and a label, because labels are, of course, important. And I will see you later. Bye.